Turn on the recorder here. We're going to be talking about site plans. So we are in Unit 8 of the textbook. Again, we'll be working on this. I'll be lecture and do one of the exercises tonight, and then next week we'll go into breakouts and work on the more detailed assignments here. And this is kind of the way we'll be doing things for the rest of the semester. We'll be looking at different aspects and spending a lot more time looking at plans and answering more detailed questions. So hopefully we've set the stage and given you some grounding in the fundamentals here. So again, what are we going to try to do tonight? Obviously, we want to recognize some of the common features of site plans. Site plans have descriptions of the property line, so we want to make sure we understand how those are shown on a site plan. Know what the difference is between true north and plan north. Understand what a contour line means. Contour line has to do with elevations. We'll plot topographic sections, and then the exercises will have something to do with contour lines as well. So that is our agenda for tonight and for Thursday. Right. So in this is figure 8-1 on page 136. So a site plan is, analogous to a floor plan, right? Remember, in an orthographic projection, we took something that exists in 3 dimensions and reduced it into 2 dimensions. Well, we will be doing the same thing here. We're flattening out a parcel of land that might have some valleys and features in it. We're flattening it out and showing it in 2 dimensions. Yes. Was there a question? Sorry. Okay. So this is the site plan again on figure 8-1 in the book. Let me turn on the pointer here. Right, so this lot number is typically some kind of legal designation of the property, right? If you look at that, if you look at this, we have 3 different lots all connected to this cul-de-sac here, right? Cul-de-sac is a, kind of a dead-end street. So we have lots 59, 60, and 61. So this lot number, I'm guessing, would be some designation of the lot that's tied to its legal description. Again, in the plative survey that we have for our house, it'll say something like, lot number so-and-so in somebody's subdivision, et cetera, right? This is the description of the property when it was originally subdivided. So that's what the lot is there, and you see that these are fairly generously sized lots, right? That looks like 2.4 acres, 3.6 acres, right? 1.5 acres. So maybe some lots in a residential subdivision, or who knows what. So again, here's the lot numbers. This line here is the property line, and recall that it's described with a bearing and a dimension. Right, bearing is its compass direction, and length is the length of that particular piece of the property line. Now, if you look at the book, it seems like they've cut some text off here in my slides. There's another set of text that says curve number, refer to the curve table below. The curve table below is basically the way that a surveyor lays out something circular like that, right? If the property line is a straight line, that's pretty easy, right? We have a bearing and a dimension. If it's something curved like this, then the layout is a little more difficult. Figure 8-1B is the curve table, and I have a slide a little later this evening where I try to explain what that means. But suffice to say, that is how a land surveyor lays out a curved property line. We see a couple of things here which I will go on to explain as well. We see setbacks, and we see ESMT period, and we see it spelled out here, easement. I'll explain what easements are and setbacks, so we can understand what that means in the context of a site plan or a plot plan. Right, so here's again, in the textbook, it has the surveyor's curve table. I picked this up off the web and stuck it here, but I have to admit that I don't really fully understand what all these definitions are as well. Suffice to say, if you're a land surveyor, this would be the business that you do. But again, this is the way that a surveyor would describe a curved property line. The radius, arc length, chord bearing, chord length. I'm actually I'll take these two things and I will post it on, or I'll stick it up on Blackboard as well, so you have this information. Again, if you're the electrician or the plumber, you may not care about what the surveyor is doing, or if you're the property owner or the lawyer, these things are important to you. Right, so on a site plan, we saw a lot and block numbers or an address. Again, that lot and block number would be part of the legal description of the property. We saw the bearing, the direction and length of the property lines, a north arrow, either true north or planned north. These dimensions of front, side, and rear yards, these will be setbacks. We'll see what that means in a minute. We might have indication if there are trees or shrubs, vegetation. We would generally see an indication what's going to stay and what might need to be removed. We'll see the contour lines, which show elevation or topography, change in elevation of the land. And generally, the site plan will show the location of the buildings and any accessory buildings on the site. Right, so in this case, right, they're not showing us any buildings yet, so we don't know what's planned for these particular plots. Again, planned north and true north, right? We live in Chicagoland, or in the city of Chicago, right? We live in a gridded out city where all our streets run, generally speaking, north, south, or east and west. Aside from Elston and Milwaukee and Archer and things like that. For the most part, if we're designing and building in this area, we don't have to worry that much about plan north and true north because almost everything lines up to true north. However, if you're building on a parcel of land that might be, not on a grid that's oriented north and south, then you might see a designation of plan north. So, and then somewhere it's going to show how plan north relates to true north. But plan north, in a case where plan north, then you would show, north elevation, east, west, south elevations, etc. And they would be the plan elevations as opposed to the true elevations because the what's called, in this case, what's called, the east elevation may actually be facing southeast. But the plan north makes it easier for us to do things like distinguish the different elevations on the plan. Right, we just saw on the plot plan about property lines. Property lines are defined by length and bearing. Bearing is a compass direction that indicates the direction of the line. The bearings are expressed as either degrees east or west of north or south. In degrees, minutes, and seconds. So degrees would be, we have 360 degrees in a circle. And then that degree is subdivided into minutes. So a minute is 1/60th of a degree and subdivided again into seconds. So a seconds is 1/60th of a minute. So again, we get fairly precise with our bearings. I should have looked around and found my compass. I do have an old-fashioned compass. I'm sure people, I don't know what surveyors use if they use compasses or GPS these days, but the bearings would come from some instrumentation that shows those directions. Right, so how do the bearings work? You see our north, south, east, west. And this particular line is a bearing north 20 degrees east, right? So we started north, and then we move 20 degrees to the east, and that's the direction of that bearing line, right? Remember, from north to east is 90 degrees. The whole circle is 360 degrees, so each quadrant is 90 degrees. So north 65 degrees east is obviously going to be more east than 20 degrees east because 65 degrees is greater than 20 degrees. So again, this would be a bearing line of north 65 degrees east. Here is north 45 degrees west, so we are in the opposite direction of that. And then here's some bearings on the south side, south 30 degrees east or south 80 degrees west. And again, remember those bearings could have some additional detail. 80 degrees, 15 minutes, 27 seconds, right, for more precision. I'm going to skip over this stuff here. I know my lectures have these slides stuck in here. There's a lot of stuff about green building that I'm going to collect up, and toward the end of the semester, we're going to talk a lot more about green building. In this case, obviously, they're reminding us as architects or construction professionals that we should try as best as possible to keep the existing trees and shrubs and vegetation on our sites. Try to protect those trees from damage, right? If you're the designer, the architect, or the landscape architect, right? You want to try to do your design such that you don't have to cut down trees. And if you're the contractor building the building, obviously you want to protect those trees from damage if the architect has indicated that they should stay. Hopefully the architect's specification will tell you how much you have to fence around that tree, and don't get too close to the tree with heavy equipment so you don't compact the roots, etc., etc. Okay, contour lines. Again, if you go camping or do outdoor activities, you might be familiar with a topographic map. This is the same idea as a topographic map. You know, we live in an area that's essentially flat, so we don't pay that much attention to topography because it doesn't concern us that much in Chicagoland. But certainly, depending on where you're building, topography or contours might be important to you. So contour lines are identifying the elevation of a particular piece of ground. All in the lines will curve across our plot plan. Any point on that single contour line will have the same elevation. The interval between the contour lines indicates a change in elevation or in a vertical distance. The interval between those contour lines will vary depending on the topography of the area. Right, in a place like Chicagoland where there isn't much change in elevation, we may have an interval between contour lines fairly small, 1 or 2 feet. You know, in a place that's hillier or where there's more change in topography, then we're going to have a greater interval between the contour lines, just so we don't have so many contour lines on our drawings. And if we see those contour lines far apart, that means it's a flat parcel or something that has a gradual slope. If we see those contour lines close together, it indicates something that is more steeply sloped. And then we can tell from the numbers on the contour line whether we are sloped up or sloped down. Again, we'll come back to this one. Right, so here's our contour lines. This is figure 8.5 in the textbook. It's a little hard to see on the slide, but you see contour lines that are in 2-foot increments. So 884, 880, you know, starting in the lowest area, the depression, right? That's 884, 886. And numbers are increasing, right? So this is higher than any of these other places. So we're basically sloping downward into a depression or a pond or something. I don't know what it is. And you see that the slope is steeper here where those contour lines are closer together. And the grade is a little bit less steep over here where the lines are farther apart. And you see what they did here is they drew this section, right? So they cut a section to try to visualize what that what that slope, what that contour looks like. They cut a section, and they basically drew it on a piece of graph paper, right? On the y-axis here, you see those same elevations in 2-foot increments, 884, 886, 888. And every place this section line intersects with a contour line, they brought it down here to its numerical value of the contour line. So this would establish a bunch of points on a graph, and then somebody sketched in or connected all the dots to try to give a visualization of what's actually going on with this feature. Again, this may better help you understand what's actually happening, as opposed to just looking at this on a contour map. This gives you a better way of visualizing what's actually happening. So again, we're going down a hill, upping more gradually on this side, more steeply over here, down to a depression. You know, whether that's wet or dry, I don't know, but right. Okay, it's the top of the hour. Why don't we take a 10-minute break, and we will continue.
Can I ask a quick question? What do the numbers correspond to on the side again? Is that like
the numbers correspond to elevation in, I'm guessing it's not specifically said, but I'm going to guess they're in elevations in feet.
okay?
So any, these lines are being imposed over a physical piece of ground. So any place on this contour line has the same elevations of 900 feet. Let's just assume it's 900 feet above sea level, or whatever the reference point is. So any particular point on this line is at 900 feet. Any point on this line is 888, 886, 898, 896, etc. So again, this gives us a way of describing the topography or the slope of this particular piece of land.
Okay, thank you.
You're welcome. Any other questions? We'll start with this again, and I'll go through it one more time, just so it makes sense. Again, in Chicagoland, we don't have anything that looks like this for the most part, but obviously in other parts of the country they do. So we want to prepare it in case you're designing or building in, say in Northwest Illinois or someplace else where there's a lot more change in grade. So we will start up again about 10 or 12 after the hour.